Okay, good morning, everyone. This morning I'm talking about quantum computer. Just introduction, nothing much. I'll talk about our normal computers, which are called classical computers, then quantum physics, then quantum computer itself, then tunneling, superposition and entanglement, then bits versus qubits and applications. Classical computer. A classical computer is just a normal computer. For example, now this is just a classical computer. We have Dell, HP, and others. In classical computers, we do calculation in the same way that we do by hand. So, for example, now let's say you want to do 2 times 2, 4 times 4. You can do the same thing with your hand and same thing with your normal computers. Now, as a result, the class of problems that can be solved efficiently is the same as the one that can be solved with your hand. A classical computer, where we call bits, which are called binary digits. This is how your information are stored. Binary digits are basic units of information storage and communications in digital computing and digital information theory. Since 1960, the power of our brain has been growing exponentially, allowing computers to get smaller and more powerful. If you look at the history of computer, the first one that came out was extremely large. Now, as the year goes by, it kept on decreasing in size. Now, the more they decrease, the more their computing power increase. However, this process is about to meet their physical limits. Computer parts are approaching the size of an atom. A computer has a transistor. Now, in a normal computer, we have a chip. Inside the chip, we have what we call different modules. Inside the module, we have what we call logic gates. Inside the gates, we have what we call a transistor. Now, as your computer gets smaller, it will reach a point whereby it will become atomic in nature. So you can't use your normal classical physics to explain the behavior and properties of the atoms. Your transistor is a switch that can either block or open the way for information coming through. However, with the parts reaching an atomic scale, classical physics can no longer be used to study the behavior of these parts, and thus quantum physics was introduced. Now let's talk about quantum physics. Also known as quantum theory or quantum mechanics, quantum physics is the study of the behavior of matter and energy at molecular, atomic, nuclear, and even smaller microscopic levels. In the early 20th century, it was discovered that the laws that govern microscopic objects do not function the same in such small realms. Observing something in the realm of quantum physics influences the physical process taking place. In fact, in quantum mechanics, we discovered that the entire universe is actually a series of probabilities. For example, now I'm writing right now doing a KD, but in another place, another world, I may be doing something, maybe eating or swimming. So that's what quantum physics is all about. Just imagine number of possibilities that can happen at once. Now let's talk about quantum computers. A quantum computer is a computer that harnesses the power of our principles of quantum physics, like superposition, tunneling, and entanglement, to deliver a huge amount of processing power. Your quantum computer just combine normal computer science and quantum physics to generate a computer that can provide a huge processing power. Now, unlike a normal computer, information are stored in qubits. Qubits just means quantum bits. While in your normal classical computer, we call bits. In your normal computer, we have what we call classical bits, while qubit is for what's called quantum computers. Let's imagine you have a coin and you toss the coin upwards. It's either you have a head or a tail, right? Which is basically 0 or 1. But the moment the coin is flipping on the air, it's 0 and 1 at the same time. So to understand the concept of quantum computing, let's play with our imagination a little bit. Imagine you are spinning a basketball on your finger. Either you spin left or right, right? Under the laws of nature, the ball spins either to the right or to the left, but never in both directions at the same time. The world of quantum computing is different. Here, the ball can revolve in both directions simultaneously at the same time. Now let's talk about superposition. Superposition is a fundamental principle of quantum physics that states that two quantum states can be added together, and the result will be another valid quantum state. And conversely, that every quantum state can be represented as a sum of two or more other distinct states. This is just saying that the coin, instead of being just head or tail, it can be head and tail at the same time. Now, tunneling. Quantum tunneling is a quantum mechanical phenomenon where a subatomic particle passes through a potential barrier. Quantum tunneling is not predicted by the laws of classical mechanics, where surmounting potential barrier requires enough energy. If you look at the diagram, you see a guy climbing on the hill. He's trying to cross over to the other part. Now, you can either go through this way or just create a kind of a quantum tunneling that will get you from here to here. Imagine us going to Mars now. So instead of traveling all the way to that distance, just create a kind of quantum tunnel that will just transfer you within a second from here to Mars. So that's what this was all about. Then entanglement is a physical phenomenon that occurs when pairs or group of particles are generated, interact or share spatial proximity in ways such that the quantum state of which particles cannot be described independently of the state of the others, even when the particles are separated by a large distance. Okay, imagine you have two coins now. You now toss it up. It's either you have maybe this one head, this one tail. But if they are entangled, they are both head and tail and tail. So the effect of one will affect the same. That I said, observe here affected over there. We all know this cartoon, what you call Spider-Verse, right? Now, this cartoon was actually based on quantum physics and quantum computer. There was a guy with a big head, I don't know his name, I think Keeping or something. He lost his wife and his son. So he was trying to get them back. So he created a machine called Super Collider. That machine was same thing as a quantum computer. Now, it was trying to open a different universe whereby he will see different versions of his wife and son. They've been back to this world. But unfortunately, he came back with different versions of Spider-Man. Now, that process, the bridge that brought this guy is called quantum tunneling. Why the superposition? Here you can see that the Spider-Man was a pig here, was a man and a lady. So different versions of Spider-Man, different dimensions. Application of quantum computer. It can be used in machine learning. It can be used in optimization. It saves time. For example, if your normal computer can take like 14 hours to do stuff, just for quantum computer, just say square it of 14 hours. That's the same time you take it to do the same action. It can also be used in teleportation. Like I said, imagine if you want to go to US without having a visa or passport. You can just use quantum computer to do that. It can also be used in cybersecurity and code breaking. In summary, quantum computer is just using normal computer science and quantum physics and combining the power of both together. And that does everything. Thank you. Any questions? Any questions? Yeah. Yeah. Okay. Quantum computer. Okay. 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 Generally, in quantum computer, you use normal computer science, the quantum physics, just combine it together. You have to a quantum computer. As of now, it's so expensive that it's only NASA, I think D-Wave and IBM that are creating the quantum computer. So for now, it's not being used now. So they're just making it now, but it's very, very expensive. According to report, it will be available in the next 10 years. It will not replace a normal computer, but there are some actions that this one cannot perform. Or it will take this one like 100 years. Now, 100 years, when you look at when you compare that one with one of quantum computer, you just take for like maybe days. So it makes your work faster and easier. Quantum computer to solve problems that just make your work easier. That's just it. Example, for example, let's say you are going to Yaba. You don't know about Yaba. You have never been to Yaba before. Okay, you can pass different routes to Yaba, right? Normally, a normal computer will just test all the routes one by one. A normal computer will test the routes one by one. This was faster, come back here, it's not faster, come back here. That took like maybe like hours. For quantum computer, you can test that route everything at the same time. Do you understand? So it does take like maybe hours, taking for a minute.
Sorry, let me just say something.
Okay.
Most of the things are physics. Most of the things are actually theoretical. So you don't see the immediate effect.
Yo,
Watch, everybody here watches Big Bang Theory. Leonard. You don't see what Leonard
Yeah.
does, but Leonard is working.
sure.
Sheldon is just writing on the board and stuff. They come up with theories, things like string theory.
Theory, yeah.
You don't see anything about string theory. But in the long run, after like a number of years or months, those things will start coming to life. That's why I said 10 years. So you cannot see all of those things. And even machine learning, everybody's talking about machine learning, machine learning. There are still some things that machine learning can do, but you cannot see
now. Sure.
Yeah, so if they are going to bring in all of those things, it might take some time. Right now, some of them are still in research stage. So that's why physics has, we deal with physical things, but for something that deals with a lot of physical things, there are a lot of things that are still unreal, that are still technical. So that's why we probably cannot get like a very serious example like animation.
But even this guy Bill said it's rubbish to him that he doesn't understand it. Said he doesn't get the point. But maybe, but now he's investing into it now because he's not getting what it's all about. So any questions? Oh, thank you.
Please, as usual, let's wait. Please also
Say stop it. Stop it, please.